Okay, a basic video now showing you how to do some implicit differentiation on some fairly standard and fairly easy examples. So I'll just do 2 or 3, perhaps 3 or 4 easy examples, straightforward implicit differentiation, no explicit techniques whatsoever. So if I did something like this, let's do number 1. Let's say I had 5x squared minus 2y squared is equal to 7. And I said to you, differentiate that. In other words, find dy by dx, but do it by implicit techniques, not explicit techniques. Implicit. So this is what I would do. First of all, I would say, well, I don't like minus 2y squared very much. That's going to be the thing that's causing the problem. But let's just start one at a time, differentiating each term with respect to x. And we'll come to that in a minute and see what the problem is. 5x squared, if you differentiate it with respect to x, 2 to the power 2 to the front, times the 5, you get 10x to the power 1, in other words 10x. I'll leave this one for a minute. Differentiate 7, with respect to x you get 0. Now minus 2y squared, you're going to get minus, and then 2y squared. Well, remember how we deal with this. Y is itself a function of x. So we use function of a function. Y, function of x, to a power function 2. Power function takes priority. Power 2 to the front multiplies the 2 there, you get 4. Power goes down by 1. So you get minus 4y. And then you go inside the original function, which is the y, because remember, it's like y to a bracket in a bracket squared. That's what's going on. So you go inside the bracket, differentiate y with respect to x, you get dy by dx, and you multiply by that. So you end up with that. And so this here now needs to be rearranged to get dy by dx as the subject of the formula. Now this is a negative quantity, so I'll probably take that to the right to make it positive. So I'll leave the 10x on the left equals 4y dy by dx on the right. And the naught obviously is plus naught, which you don't need to put in. Okay, so next I want to get dy by dx on its own as the subject, so that'll become the subject on the right hand side. And you get 10x on the left divided by 4y on the right. This will cancel down. This is a single fraction. Cancel it down. Share by 2. Top and bottom. You're going to get 5x over 2y equals dy by dx. And that answer there is how you leave it, because x and y are in the answer, and that is a perfectly valid answer when you are using implicit techniques. You do not need to eliminate the y and get the answer just in terms of x's. And that's the end of the question. Very straightforward example. You could do this example by explicit techniques. Explicit techniques will work for this one, but I'm not going to do it by explicit techniques. There's the answer for implicit. Okay, if I have a look at number 2, let's do a very similar standard question. Let's say I did x squared y is equal to 10, and I said to you, let's differentiate that implicitly. Okay, so we've got x squared y, which is one term on the left, and we've only got one term, number 10, on the right. The one on the right, if you differentiate it as it stands with respect to x, is just 0. Differentiate this as it stands with respect to x. This is a product of two functions of x. X squared is the u in a product rule we're going to do, and the second function is the y. Y itself depends upon x. So the v will be y. So x squared is u and the v is y. du by dx is 2x, and dv by dx, you differentiate this with respect to y, you get dy by dx. So those are the 4 things that you need for the product rule, which remember is u dv by dx plus v du by dx. And I would say to you, I'd always put a little heading above this telling the examiner what this working out is all about, how to differentiate this with respect to x. Because in some questions you may have 2 or 3 of these type of terms in a longer, more complex question. So I do a little heading and calculation for that, and if need be, underneath it I do another heading and a little calculation for another term such as that may be in a more complex question. So you may have three or 4 of these all at the side of the page working out product rules for the long-winded question that you've been faced with. In this case, there's only this to do. Right, so here we go. U, that's x squared. dv by dx, that's dy by dx, plus v, what's that? That's y, times by du by dx, well du by dx is 2x. Put it in a bracket if you want, but there's no need to. So let's just sort this out now. This is that there being differentiated gives two terms, that plus that. Of course this is going to tidy up and you write the number first, then the x and the y, so this thing is the same as 2xy. Leave that there. And we'll leave this here alone for the moment. So I'm just tidying up and you get that. What we do now is rearrange this to get dy by dx in its own. So x squared dy by dx, leave it on the left and take the 2xy to the other side, you get minus 2xy. And then what I'd say is you divide both sides by x squared, so you get minus 2xy all divided by x squared. And of course this is a single fraction, x on top and bottom, divide top by x and divide the bottom by x. And there you go, there is your answer for implicit differentiation for dy by dx, and you can leave y in the answer. You do not need to convert it all into x's. And again, you don't need to do this by explicit techniques if you are told to do it implicitly, and I am telling you here in this video we are only doing it implicitly. So that is the final answer. Okay, let's have a look at a third example. Now sometimes in the examples that you're being faced with, you may be asked to make use of, say, some standard results that you've got to use. So for example, you might have something like this. You might have 2y e to the x is equal to 7, for example. And I could say to you, let's differentiate that with respect to x to find dy by dx using implicit techniques. So here we go. On the right hand side we've got one term, differentiate that with respect to x, you get 0. Now the left hand side, you've got to differentiate that with respect to x. Now again what we've got is a product of functions of x. You've got an e to the x, which is obviously dependent on x, and this is being multiplied by 2y. And 2y is itself dependent upon x. Y depends upon x. Y is a function of x. If you were to rearrange this to get y as the subject, you had y equals so many x's. So that is the first function in a product of functions. So u is 2y and v is e to the x in this question. I'll put the heading because we are trying to work out what 2y e to the x differentiates to give when you differentiate with respect to x. We're going to use the product rule, u and v. You need du by dx and you need dv by dx. Well, I'll do this one first. This is a standard result that you got to know. You're supposed to know this from previous work. If you've got v equals e to the x, you now need to differentiate it with respect to x. If you remember the standard result, it stays the same. That's easy. Okay, we now differentiate u with respect to x. So you differentiate 2y with respect to x. And all you've got to do is write down the 2 and say differentiate y with respect to x, you get dy by dx. So you're going to get 2 dy by dx. It's simple as that. Don't need to worry about the 2, it just multiplies the y. So you get 2 lots of dy by dx when you differentiate with respect to x. We now make use of the product rule, which is u dv by dx plus v du by dx. And we sub in the 4 values and put them here. So u, 2y. dv by dx is e to the x. Plus v, that's e to the x, times du by dx, and du by dx is 2 dy by dx. Okay, I'll put the 2 at the front, just for neatness, and then dy by dx at the end. That's the order we'd put it in. The number first, then the e to the x, and then the dy by dx. Okay, so that's the first step done. We now rearrange this to get dy by dx on its own. So what we're going to do is leave the 2e to the x dy by dx where it is, positive on the left. Take this to the right, you get minus 2y e to the x on the right. Divide both sides by 2, in other words the 2's just disappear. Divide both sides by e to the x. The e to the x's just disappear. You could do this if you want. I'll just scribble it here so you can see what I mean. You could say dy by dx equals, and then write minus 2y e to the x and divide it by 2e to the x and do the cancelling at this stage. it doesn't really matter. However you do it, this way, or divide both sides by 2, divide both sides by e to the x straight away, you end up with dy by dx is equal to negative, you leave the y there, and I think everything else is cancelled. And there is your answer, and you can leave y in your answer for that particular question. You don't need to convert it back into x's. Again, this example here, you could do this one again by explicit techniques. It's perfectly possible to do it, but you don't need to do it if you're told to do it by implicit. You're perfectly entitled to do it this way and leave the y in the answer. So there you go. There's 3 basic examples which could be done by explicit techniques, but I have purely done them by implicit methods. And that's the end of this little video.